Hi class, this is Mrs. Lyons. This video is going to hopefully explain bond polarity to you a little bit. We talked about bond polarity back when we were doing periodic trends, okay? And if you remember, electronegativity we said was higher at the top and to the right. Okay, so if you see this table now that we give you, you'll have this on the back of your periodic table. It's a value, it gives each atom an electronegativity value. And if you notice, fluorine has the highest electronegativity. Okay, so what does that mean? Electronegativity is the tendency of an atom to attract a pair of electrons in a bond. Okay, and typically we use this with covalent bonds, and we talk about covalent bonds being polar or nonpolar. Okay, and this, you'll also have this table. It says differences. So what that means is if I take two atoms, for example, if I took fluorine and oxygen, and I took the difference, fluorine is 4.0, oxygen is 3.5, the difference would be 0.5. Okay. What that would tell me is my electronegativity difference is 0.5. That's what we call a polar bond. Okay, anything less than 0.4 would be a nonpolar bond, and anything over 2 is going to be classified as an ionic bond. Okay, now when we have something with a value over 2, we're not talking about the electrons being shared in this case. When we have a value over 2, we call that ionic. And what happens in an ionic bond is the nonmetal is going to take the electrons from the metal and form an ionic bond. Okay? So here's the other thing. If you look at a compound and you see that you have a metal and a nonmetal, it's automatically going to be ionic. You don't have to look at the electronegativity values, okay? So if you look at a compound and you see one metal and one nonmetal, you're going to classify that as ionic, okay? So let's talk about what happens in covalent bonds, okay? If the electronegativity value is less than 2, the atoms are going to form a covalent bond and share the electrons, all right? Atoms in a covalent bond do not always share the electrons equally. All right, if one atom has a higher electronegativity, and if the electronegativity difference is big enough, that atom with the higher electronegativity is going to hog the electrons. Okay, in other words, the electrons are going to be attracted to the element with the higher electronegativity. All right, and what we call that is a polar bond. So a polar bond is any time that the electronegativity difference is between 0.5 and 1.9. All right. If the bond is less, if the electronegativity value is less than, or is 0.4 or less, we're going to classify that as a nonpolar bond. And what happens in a nonpolar bond is the electrons are shared equally. All right. Polar bonds, the electrons are not shared equally. So if we look at this picture, all right, we have this picture, and this area, this atom, the larger blue portion, what that's telling us is that the electrons are going to spend more time around this atom than they are around the red atom. Okay, and we use these signs. This sign means partially positive. This means partially negative. Okay, so what we see in a polar bond, because the electrons spend more time around one atom, that atom carries a partially negative sign. Not a full negative sign, but it's more negative than the other end of the atom. In nonpolar bonds, the electrons are shared equally, and you would see it like this. Okay? So, when we have a polar bond, we can draw this thing called a dipole arrow. And the dipole arrow points towards, it has a positive sign over the less electronegative atom, and it points toward the more electronegative atom in a polar bond. If we have a nonpolar bond, we don't need to draw that arrow. All right, so let's look at some examples. Water, H2O. So if I drew the Lewis structure for water, I would have a single bond between the hydrogen and the oxygen, and then remember we would have these two lone pairs of electrons up on the oxygen. And you'll see water drawn like this because this is a better representation of the true shape of a water molecule. And that's what we're going to be talking about in our next lesson, is molecular geometry and shapes. All right, so I'm going to look at the electronegativity table, and it's going to tell me that the electronegativity of oxygen is 3.5 and hydrogen is 2.1. So if I take the difference, that gives me an electronegativity difference of 1.4. So that means oxygen has a higher electronegativity, so the dipole arrow points towards the oxygen. So we have two dipole arrows pointing towards the oxygen. This means that oxygen is going to be much more negative than the hydrogen end of the molecule. And we would classify the hydrogen-oxygen bond as polar. Okay, let's look at another example, CH3F. Okay, if we look at this, if you look at your electronegativity values, okay, the hydrogen-carbon bond, all right, if you look at your table, hydrogen has an electronegativity of 2.1, carbon has an electronegativity of 2.5. That's a difference of 0.4. So we classify that CH bond as nonpolar, so we don't need to draw the dipole arrow. All right, the bond between the carbon and fluorine is polar. Carbon has a value of 2.5, fluorine is 4.0. So we would draw an arrow here going from the carbon towards the fluorine. And this kind of makes sense if you look at this. This fluorine has all of these electrons around it. Okay, so it's much more polar than carbon. All right, so what I'll ask you on a quiz or a test is to tell me, I won't ask you to draw the dipole. It's just kind of a way to visualize things. But I will ask you to look at the bond, and you would tell me that the CH bond is nonpolar and the CF bond is polar. One more example, pH3. All right, so here's the Lewis structure for pH3. If you look at this, we just have one bond, just the phosphorus hydrogen bond. If we look at our table, phosphorus has a value of 2.2, hydrogen is 2.1, so that's a difference of only 0.1. So the bond between phosphorus and hydrogen is nonpolar, so we don't need to draw the dipole arrow. That bond is just a nonpolar bond. Okay, so hopefully this will help you understand, this video will kind of help you understand bond polarity, and we will go on with it, and the next thing we'll talk about is molecule polarity. All right, so I hope this video was helpful. I will see you in class. Take care of yourselves.